Good morning, everyone. Welcome to science class. My name is Mrs. Kearns. Your regular teacher, Mrs. Absent, was unable to be here, um, but she did leave us some lessons for today. Today, we're going to talk about the states of matter. So if you want to go ahead and turn on your cameras so I can see your faces, we could go ahead and get started. So today, as I just mentioned, we're going to be teaching you about the states of matter. We're going to learn the definition of the states of matters and some properties of different states and the differences in the states of matter. Okay, so first I'm going to go ahead and bring up a little diagram here as a reference that we can look at. And first off, let's take a look at the picture on the top left. And if you look at the picture, we see trees and we see sand, and if you can't tell, that's blue part behind the sand is water, the ocean. And there's trees and we see some clouds. And all these things that are in our world, they're all matter, all made of matter, different types of matter. We see the water, it's a liquid matter. We see those sand and the trees, they're not liquid, they're solids. And then if you look up in the sky, you see the sun, you see the clouds, they're gases. And those are the three states of matter. Okay, we firstly need to know the definition of matter. What is matter? Well, matter is anything that occupies space, has weight, and actually, I have here a glass. This is like this paperweight. It's a solid object. It's got weight, takes up space. It's not moving around. It's not flowing anywhere. I can see it. And the shape of this is just not going to change. Okay. And we can look around us. You can observe most of the things that you're going to see around you are solid. Your desk, your computer, all of these things. And so, I mean, what defines a solid? Well, in a solid, the molecules are arranged tightly and close together. It has a fixed shape and volume. So as you guys remember from last year, that everything around us is made out of small particles, molecules. And when we are thinking about a solid, these molecules are going to be tightly interacted. So they don't really move. They just stay together. Like in this, it's tight, it's hard. It's just not going to change shape if you can feel it. There are some solids that can change shape, I guess, if you think about clay or something, but it's still something that you can hold on to. It's not flowing between your fingers. It's going to stay in your hand. And okay, so we've thought about solids. So what would be difference about a liquid? For example, liquids, the molecules are looser together. They do not have they have a fixed volume, but they do not have a fixed shape. So the shape of anything that is liquid is going to take on the shape of a container, like my water, see it like this. Things that are liquid, we have blood, we have water, we have your coffee. Coffee takes on the shape of this cup, but it has the same amount of volume. The amount of this, it's not going to change. It's not going to go up, down. It's just going to stay in the shape of the cup right about there. And that's the difference between, say, a liquid and, say, a gas. For example, too, if you look on the bottom left-hand side, you see gas does not have a fixed shape, and it doesn't have a fixed volume. Do you see the little yellow X's? They're all over the place. They're not tied together. They're not in a boundary like you would see in the liquid diagram at the top. They can just kind of come apart, and the gas can go all over. Like you see clouds, they change shapes, and the gas disperses. Or if you think of an example of gases, can you see what's different about a gas? Anybody in your chat? You can't. No, you're right. You cannot see it for the most part. Sometimes you can smell gases. Yes, somebody's putting in car exhaust. Yes, but there's no fixed shape of it. It's just going to dissipate. You know, the molecules will get farther and farther apart, and it will spread however it wants to. Another example of a gas is, helium. Someone typed in helium. Yes, it can only be constrained because it's in a balloon. If you put it in a balloon, it will take the shape of the balloon. But, you know, if you were to let it out of the balloon, it's going to dissipate everywhere. The molecules will continue to get farther and farther apart and spread, like our diagram right there. Okay, you can feel gases, like with the wind. Now, as you can see, like in our diagram and what we just talked about, everything on the earth is made out of matter. The water we drink, the air we breathe, the ground we walk on. Matter has color, it has temperature, it has texture. Some is visible, some of it is not. And some matter can even change its state. So changes of matter happen as a result of the changes of temperature around the matter. It can change by adding heat. It can change by taking the heat away. Changes of matter, you can enter them in your chat, different examples. What are some examples of changing from one state of matter to another? For example, liquid to solid, or solid to liquid, from a gas to something else. Anybody, what do you guys think? Okay, yeah, I see melting, right. When ice can melt, it becomes a liquid. You can melt plastic, you can melt chocolate. All these cases, something is going from being a solid to becoming a liquid, and that's by increasing the temperature. Any other examples that you can think of? Freezing, that's right. If you freeze water, you freeze some liquids, they will become solid. Another example of that could be like if you make Jell-O, for example, it gels. What about gases? Can gases change state? No. Okay, yes, gases can change state. Gases can change state. If you have a water vapor, for example, condensation, it will become a liquid. That is an example of a gas changing state. Okay, we know now that all matter is made from molecules, that all matter takes up space and it has mass, that matter exists in three forms. It exists as a gas, it exists as a solid, and it exists in a liquid. We know that matter can change its form by the adding or removing of heat. Okay, that is all for this lesson. Does anybody have any questions? Okay, I have sent you all an activity, some questions that talk about and ask about the things that we went over just now in this lesson. It will help us know if you have achieved your learning goals for today. If you can turn them in today if you like. If you need extra time, you can take the weekend to do it. Just as long as we have it in your Dropbox by Sunday night, that would be okay. So that's it for today. So you guys have a great weekend, and we'll see you next time. Thanks. All right, I just want to add that this lesson actually falls into the PA 3.2 physical science standard. And I did mention that the students that need extra time could take extra time the weekend to do that. And the activity at the end of the lesson will assess whether or not the students learned the assigned the goals for the lesson. And I did address the class so that they would know that I was substituting for the regular teacher as well. Anyway, thank you very much. Bye-bye.